Hello everyone, Mr. Fawcett here, and we are back with another Algebra 1 lesson. Throughout this unit, up until this point, we focused on adding, subtracting, and multiplying polynomials. Today, we're going to talk about the reverse process of multiplying, and that is factoring. And there's many different types of factoring, so we're going to spend a couple lessons on it. Today, though, we're going to talk about factoring using the GCF method, and we'll talk about what those letters stand for in a minute. For our do now, it says find the GCF of the following terms. Well, I guess we got to define what GCF means if you're going to do the do now problems. So GCF stands for greatest common factor. Now we need to know what factors are, right? And that certainly should be a review word. But factors are numbers that multiply to get a different number, right? So if I want to find the greatest common factor of 6, 15, and 24, I've got to find a number that I can use to multiply to get to 6, to 15, and 24. So a couple different ways you can do this. You can break it down by using a factor tree. Probably worked with those before. So two factors of 6 are 3 and 2. And I can't break down 3 and 2 anymore, right? Both of those numbers are prime. So our factors of 6 are 3 and 2. We also have to remember that there's also, 6 and 1, right? 6 and 1 are also possible factors. So I don't love the factor tree here because the factor tree gives you the prime factorization of a number, but it may not give you all the factors of a number, right? It would give me all the factors of a number if I did 6 and 1, and then I broke down 6 to 3 and 2. So then I can actually see all the factors. But, depending on what numbers you start with, the factor trees may not give you all the factors. So what I recommend doing is writing them in a list. So if I think about the factors of 6, well, 1 is a factor of 6, because I can divide 6 by 1. 2 is a factor of 6, 3 is a factor of 6, and 6 is a factor of 6. So the factors of 6 are 1, 2, 3, and 6. If I do 15, well, of course, I have 1. I've got 3. I've got 5. And I've got 15. If I do 24, I have 1, 2, 3, 4, 6, 8, 12, and 24. So even though 24 doesn't seem like a very large number, it does have a lot of factors. Now, when it says find the greatest common factor of all three of those numbers, well, I'm looking for the highest number that appears in all three lists. So right away, we should know that the greatest common factor cannot be a number greater than 6, right? Because 6 is the largest number in my first list up here in red. So if I look, 6 doesn't appear in all of the lists, just appears in red and green, so that can't work. Let's look at 3. 3 appears in the first list, the second list, and the third list. So 3 is our greatest common factor. And we don't even need to check the other ones, right? Because all those other numbers are less than 3. So if 3 works, well, that's got to be the greatest common factor. Probably something you've done before. I hope so. I hope this isn't the first time you're doing GCF. But today, we're not only going to do the GCF with numbers, we're going to have to do the GCF with terms that may involve one or multiple variables. So let's do an example here. If I want to list out the factors of these three terms, I've got x squared times y cubed. Well, I've got two x's that I'd multiply together. X times x. I have 3 y's that I want to multiply together. Y times y, times y. Now you'll notice I'm writing this list a little differently than I did the numbers. I'm actually just, writing out the total number of variables for each variable, right? There's 2 x's that I need to multiply together and 3 y's. So if I multiplied all of these together, that would give me x squared times 3y. It's not the case over here, right? If I multiply all of these together, I am not going to get 6. I'm going to get a number much larger than 6. If I write out my factors of x cubed times y, well, I'd have to multiply x by itself 3 times, and then just a single y. If I look at, we'll do blue, x to the 5th times y squared, that's going to give me x times x times x times x times x times y times y. So when you're looking at the greatest common factor for variables, it works a little differently. We're going to find the largest number of the same variable that appears in all 3 of these lists. So in essence, how many x's, what's the most amount of x's that are found in each list? Well, it can't be more than 2, right? Because there's a maximum of 2 x's, so x squared in our first term. And there's 2 x's in every term, right? So the first part of our GCF is x squared, x times x. Now we need to figure out what's the most amount of y factors that appear. Well, I've got 3 y factors here, but wait a second. This second term only has 1 y factor. So it's not going to be 3. The most it can be is 1, right? Because that's the most that appears in my second term. So there's 1 y in all 3 terms. So my greatest common factor is x squared times y. That is my GCF. If I have more x's, well, there's no more than 2 x's in all of these, right? Because the red only has 2 x's. So I can't have an x cubed or an x to the 4th. For my y, the green term only has 1 y. So my GCF can include at most, or exactly in this case, it has to include exactly 1 y. Okay, that's a little breakdown of how to find the GCF based on whether you have a number or based on whether you have a variable in your term. And sometimes you could have both, as we'll see later on. So if you're unsure of what we just did here to find the GCF, you may want to listen to this again, because we're going to move a bit more quickly in our example problems when we're talking about the GCF. All right, let me erase this. So it says, in our previous lesson, we practiced multiplying polynomials. The last half of this unit will deal with the reverse process. Again, that is called factoring. The first type of factoring that we will look at is called the greatest common factor, GCF. This involved finding all the shared factors that, well, there's some typos here. It's going to be fixed on your paper by the time you see it, but let me fix it now. So this involves finding all the shared factors that each term in a polynomial shares. Note that these factors can be both numbers and variables. So we're going to factor this polynomial below, 16x to the 4th minus 10x cubed plus 22x squared. So when you're doing the GCF, you've got to first focus on the number portion, and then you've got to focus on the variable portion. And we can do both separately and then put them together at the end. So let's look at 16, 10, and 22. Now you could go ahead, and maybe we'll do this one more time, but you could go ahead and write down all the factors of 16. So 1, 2, 4, 8, and 16. Then you could write down all the different factors of 10. So 1, 2, 5, 10. Then you could write down all the different factors of 22. 1, 2, 11, 22. And then you could go through and pick the largest one, right? We know it can't be any larger than 10 because 10 is the largest factor that appears in the green term, in the 10. So it has to be a number 10 or less. 10 does not appear everywhere. Now, we could look at 8, because that's the next number less than 10, but 8 does not appear everywhere. 5 does not appear everywhere. 4 does not appear everywhere, but 2 does appear in every number. That is the largest factor, or the greatest common factor, between all three of these numbers. That's 2. So I know that my GCF, part of that is 2. That's the number portion. Now I got to figure out the variable portion, right? So we can break down our x's, because there's no y's or m's. There's only x's here. So x to the 4th, well, that's x times x times x times x. Well, I've got x cubed, x times x times x. And I've got x squared, so x times x. So the largest amount of x's that appears in all three terms is 2. There's an x times x in all of these. So the rest of my GCF is x squared. My total GCF is 2x squared. So the GCF of all of those terms is 2x squared. Now, we haven't actually done any factoring yet. All we've done is find the GCF. The factoring process involves factoring that out of those numbers. So here's what I'm going to do. Let me write this off to the side so we can use this full middle piece. So my GCF, I know, is 2x squared. Now, factoring is another word for dividing, right? I need to divide this 2x squared out of all three of these terms. I'm going to put it on the outside of parentheses. You know what? Let's move it down even further. 2x squared. So I need to figure out if I take out, or if I factor a 2x squared out of all three of these terms, what's going to be left inside of my parentheses? What's left after I factor it out? Well, again, factoring's like divide. So it's like I'm dividing each of these terms by 2x squared. And we've done this when we've done exponents, right? We've talked about how to simplify quotients when there's exponents involved. So 16 divided by 2 is 8. X to the 4th divided by x squared, I subtract the exponent, so 4 minus 2 is 2. If I move on to my middle term, negative 10 divided by 2 is negative 5. X cubed divided by x squared gives me x. 22 divided by 2 is 11. X squared divided by x squared, well, that's just 1, so I can just leave it. Let's move this parenthesis in a little closer. So factoring using the GCF gives me this answer. Again, think of factoring as dividing out or pulling out the GCF from all three of those terms and figuring out what's left. What's left is going to go inside of those parentheses. Now, you may think, well, how do I know this is correct? Well, a way to check, maybe some of you are already thinking about this, a way to check would be to multiply or distribute the GCF to all three terms. If you multiply that out and you get what you started with, well, you know you did your factoring correctly. If you get something different, then you know you did your factoring incorrectly. You don't have to do that. It's just a way to check, right? And sometimes it's good to check when you're first starting to learn factoring because, you're not as good with it. But, a couple months down the road, you'll never need to check because you're just proficient at factoring. You know how to do it. So this right here would be considered our final answer if we have factored using the GCF method. Okay, I know we're already about 15 minutes in and it feels like we haven't done a ton, but let's do a couple more to practice. We're going to do the one on the top right, and we're going to do 18. Okay. So we're going to do this one right here. Pause the video. See if you can do the entire process of not only finding the GCF, but then factoring the GCF out of the polynomial. Okay. So again, I'm not going to go through the whole process of finding the GCF, like writing out all the factors, etc. If you want practice with that, you're free to do it on your own paper. Just for sake of time, we're just going to talk about it instead. So the GCF, the number portion is going to be 3. 3 is the largest factor that goes into both 15 and 18. Now my variable portion, well, you may think it's x, 3x, but that's not correct, right? Because this 18 does not have any x's. So an x cannot be part of my greatest common factor because one of the terms does not have an x in it. So in this case, the greatest common factor is just 3. So I'm going to factor that out. I'm going to put my 3 on the outside of parentheses. When I divide 15x squared by 3, that gives me 5x squared. When I divide 18 by 3, that gives me 6. So I get 5x squared plus 6. That would be a completed GCF factoring. And this one may seem a little easy, right? Because there were no variables to factor out. But that just worked out this way because one of the terms didn't have any variables. So we could not include a GCF in our final answer. Again, I did say we're going to do 18, so let's jump down there. All right, so the first thing we're going to do is find the GCF before we factor it out. So the number portion of the GCF, the greatest common factor between 18 and 9, is actually 9. 9 is the greatest common factor of 9 and 18. Now the variable portion, notice that there's 2 variables attached to the 18, but there's only one attached to the 9. So the x cannot be a part of our greatest common factor because the 9y to the 5th does not have any x's. So x's are going to be left out. And the most amount of y's that appear, the most amount of y factors are 2. Right? There are 2 y factors in this term and 5 in this term. And we have to take the smallest, right? Because the most amount of y's that appear in both terms is 2. So greatest common factor, 9y squared. Which means 9y squared goes on the outside of my parentheses, and I'm dividing both of these terms by 9y squared. If I divide 18 by 9, I get 2. If I divide y squared by y squared, I just get 1, so I can just leave it. And I got to keep my x to the 7th, because there's nothing to simplify those. 9 divided by 9 is 1, so you can put a plus 1, or you can just leave it. It doesn't matter. Y to the 5th divided by y squared gives me y cubed. So I should get 9y squared times the quantity 2x to the 7th plus 1y cubed. If you want to leave the 1 off and just say y cubed, perfectly okay. In fact, what I have on the screen now is probably what you'll see as an answer choice if it's multiple choice, or it's what you'll see written in a book, etc., because it's the most simplified version. All right, it doesn't look like we're going to have time to get to the word problems. I'd like to keep this under 20 minutes. So we're going to stop there. Feel free to work on those problems on your own off video. You can let me know if you have any questions, but we are going to stop here. As always, enjoy the rest of your day, and we will look forward to seeing you next time with a different type of factoring.